So this is the configuration of the GPIO pins on the ESP32 as they're currently set up in the include files of the project. So on the left hand side over here, I've put all the connections to the LCD, touchscreen and SD card hardware, which leaves all the pins on the right hand side for use in the application, which makes kind of a neat kind of separation between the left and the right hand side of the actual development device. These three pins down the bottom, these are the SPI pins for the clock, the input and the output signal, serial signal, and they're shared between the LCD, the touchscreen and the SD card. Now the touchscreen, I found that I needed 1K resistors on each of these lines between the device and this, because of the touchscreen I'm not sure if it completely switches off its output on these pins when the chip select isn't selected, but I found that I needed 1K resistors just for the touchscreen device onto these pins. And then apart from these pins, so these are the pins which are shared across the devices, but then each device has its own chip select. So the LCD has its chip select there, touchscreen has its chip select there, and the SD card has its chip select there. And then a couple of devices have additional pins. So the touchscreen has an interrupt input here, which I can use so that it doesn't have to poll the actual touchscreen. The touchscreen can tell the device when someone's touched the display. And then the LCD has an LED backlight, which is down here, and the LCD reset as well. And then this pin up here, the LED indicator, is actually an LED on the actual device, which is around this kind of point on the board where I've highlighted there. It's the actual LED is like a development LED. So I've just highlighted that here. If you look at the other videos, you'll see that I flashed that LED. So each piece of hardware has its own C file, so which could consider a driver. So the LCD one is there, the touchscreen one is there, and the SD card one is here, and that separates out each of the pieces of hardware into its own set of source code. Each one contains the functions to control that particular device. On the LCD, there's a lot of graphics primitives here defined in the actual LCD source code. I wouldn't use these ones. These ones will actually communicate directly with the LCD and plot points on the LCD itself. There's a file called graphics.c, something like that, and that has the actual primitives, the drawing primitives, which use the DMA, and they're much faster to use, so I'd use those ones instead of the ones you see in here. The only one that you can really consider using in here is the LCD bitmap, which can just send a bitmap straight to the LCD display, and that does use the DMA. There's other ones that you might want to use, like LCD CLS and things like that, which aren't the graphics primitives, which actually interact with the hardware to do some of the features of the actual hardware. And then the touchscreen functions you find in this file. And you probably won't have to use most of these. The touchscreen itself is integrated into the source code, so it uses interrupts to tell the source code when someone's touched the screen and to pass the information of the location on the screen whether it's actually been touched. You can dive into these functions if you want, but just to get the application running using user interactions, that's all currently in the source code, and so this is just here really just to tell you that that's where the hardware driver for the touchscreen stuff is, and the SD card has its own set of functions. It doesn't have to do much. All of the hardware stuff has in it initialization function. Some of them has close functions for it, and on this one it has functions to read a file and read a file which is compressed and uncompress it. The SD card is automatically mounted on a file system /SD card that you can use it directly in the application with file functions such as fopen, so you can fopen /SD card whatever your file is, or whatever directory then the file that you want to open is. And I've by default in the actual project I've mounted a SPIFFS file system which is on the program flash memory, so I've created a partition on there. So if you didn't want to use the SD card slot, you could just use the the flash drive, which is the program flash, and place files on there, which you can get to through this this particular directory, which is /spiffs, then / your file or subdirectories and your files. So this is the project directory, and in the project directory you see there's this directory here called spiffs_image, and this is the actual directory of files which will get written to the device when you flash the device. So you can actually pre-put files in the spiffs file system as part of the project. So in here I've got a readme file which just says place files and directories here that you want to actually go onto the flash device, and it will come up as a mounted device /spiffs. If you want stuff on the SD card, then that's easy. What you do is create a FAT file system on the SD card, and when you plug it into the device, then it comes up as you have to have the SD card in the device when you boot the device, because that's at the point it mounts. But that gives you the file system /SD card, and all the files will appear in there that you've put in your FAT file system on the SD card